Hi everyone. So let's solve this problem. So it says let's solve A first. I'll make it a short video, and we'll solve B afterwards. So let A be a positive integer, and the square root of A is rational. Prove that the square root of A is an integer. So first of all, um, we assume that the square root of A is rational. So that means you have m over n is equal to the square root of A. So that means that m squared is equal to n squared multiplied by A. So factor A as products of primes. So we have m squared is equal to n squared multiplied by p1 alpha 1 pn alpha n. So first case is that if A is a perfect square, so then all of its powers are even. If it's all of its powers are even, we get that it's a perfect square. So then that means that the square root of A is an integer. So assume it's not a perfect square. So if A is a perfect square, then the square root of A is an integer. So assume it's not a perfect square, then one of its powers is odd. And then one I exist such that alpha I is odd and bigger than 2. Bigger than 1. But yeah, let's just assume that. And then you can write m squared as n squared multiplied by p1 alpha 1 pn alpha n, where we adjusted the products here. Or more formally, you have pi alpha I minus 1 pi plus 1 alpha I plus 1 all the way to pn alpha n. So you can write this as n multiplied, so n squared multiplied by p1 alpha 1 all the way to pn alpha n. So here I solved this one before, but it's just a little bit generalized. So here you can show that P divides M, so then it must appear even number of time in M squared, and so you can show that P divides N, so P divides M and P divides N by the same argument as we did earlier. You can compare powers after that and use prime factorization theorem. Factorization theorem, and then you conclude that that is not possible. So you conclude that you get even powers. Even power is equal to odd power, which is impossible. So then it has to be true that M over N is an integer, as the main core of the ideas is that the prime P cannot just appear out of nowhere all of a sudden. It must come from somewhere, and it cannot come from two things, because squaring it allows us to get the fact that it is shared between both, and so you can cancel things around as it appears one extra factor in the square root. So that's the main reason. So yeah, I hope you guys enjoyed the video, and I'll see you in the next one. Bye.